Welcome to the students of our online lecture videos. So today we are going to see the topic of multiplexer and demultiplexer in digital principles and computer organization course. So myself, Dr. S. Sudhakar, Associate Professor, CEC Department, SSMIET. So these are the topics we are going to cover today. So introduction about those things, multiplexer and demultiplexer, and the symbols, the basic symbols, what is multiplexer and block diagram, logic symbol, logic diagram, and truth table of the multiplexer. This is the whole summation of multiplexer. Likewise, for we will see in demultiplexer also. So block diagram, definition, logic symbol, logic diagram, truth table, and what is the application of MUX and DEMUX. Digital logic gate symbol. These are the very basic gates I'm displaying here. So AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate. This is the basic um, mandatory to know, okay, to learn this kind of topics in digital principles. I hope you all know about that. So AND gate, it is then this is the truth table for AND gate. So both inputs are high, output will be high. For OR gate, so any one input will be high, output will be high. For NOT gate, there is an toggle condition. For NAND gate, there is inverse of AND gate. For NOR gate, there is inverse of OR gate. For XOR gate is exclusive OR gate. So here, any one of the input, any one of the available input is high, output will be high. Okay. In OR gate, if any one input is high, output will be high. Here, it must any one is high, output will be high. So multiplexer, the definition of multiplexer is many to one, actually many data into one output. So we call it as a data selector. So why we say we will see why it is called a data selector. So it is the process of transmitting a large number of information over a single line. So we have the common line, single communication line is there. We have more number of informations are transmitting there. Okay. So what happened? So MUX is a combinational circuit that select only one digital information from the available sources. So this is the thing. So in the several sources available in a common single line, from that we can select any one. So select any one and transmit the selected informations to a output line. So this is the whole definition. So that why we call this data selector. Data selection happened from the several sources available in a single communication channel. Okay. So it has several data input line and a single output line. So how we can select one from more information. So there is a thing we need called as selection lines. So that selection lines, technically we speak, it is control bit word in the communication channel in our circuit. So it contains the overall, the multiplexer, the circuit contains data inputs. There is a several informations and the selection inputs, what we pick up the selection lines and the single output. There is a three major element is there in the multiplexers: data, output, input, data, output, selection input. So it is like, it is act like a switch. We can switch what we want, we can select what we want. Yes, and connected to the output. This is the block diagram. We can see the block diagram. I'm mentioning the block diagram for 4 is to 1 max, many to 1. Output is 1, it is a fixed one. Or input is we can able to vary. So 2 is to 1 max is available, 4 is to 1, 8 is to 1, 16 is to 1, 32 is to 1, 64 is to 1, and likewise it will be going on that. So here this is the diagram for 4 is to 1. Input 0 to 3, there is a 4 input, 1 output, there is a 2 selection line. We can choose the selection line based on the input available. 4, if you choose the 4 as an input, there is an equivalent to 2, 4 equivalent to 2 power 2. So the 2 selection line we need. So if in the case 8 input, 8 2 means 2 to the power 3, there is an, that time we need 3 selection lines. Let me see that. So this is the symbol, the same thing what we discussed. That is this, diagram, block diagram. This is the logical symbol. 4 is to 1 max. There is a 2 selection line, 4 input data, 1 output data. And this is the logical diagram. Logical diagram contains AND gate, OR gate. So each AND gate having the 3 input, 1 output. See that? 1 AND gate. There is a 4 AND gate because of 4 inputs are available. If it is 8 input, 8 AND gates are needed. If it is 16 input, 16 AND gates are needed. Okay, if it is 4 input, I am choosing the 2 selection lines. And if it is 8 input, I am choosing three selection lines I will use. Okay, so each AND gate having the corresponding input and the two selection lines, and likewise we can connect it for 4 AND gate, and whole summation the 4 AND gates output was connected to the OR gate, and we will get the output as Y. So this has happened if based on the selection line there is a possibility of two selection line S0 and S1. I will show the truth table for 4 to 1 max. Based on this only we can conclude that operation of a logical diagram. So if it is 0 0, selection line is 0 0, we can get the output as first data as an output. If it is 0 1, the second data input considered as an output. If it is 1 0, the third data input will be coming at the output, and 1 1 means the fourth input data will be coming out at the output side. So this is the operation I will um, try to convey. So this is the multiplexer. So ultimately it is a single output from the many information digital source. This is for your view, it's a 8 is to 1 multiplexer. D0 to D7. See that here I am using the 3 selection line, 8 input line, only 1 output line. So for 8 input, I am using the 8 AND gate. Each AND gate having one data input, another 3, another the remaining input as a selection lines. Yes. So let me start the demultiplexer. The same thing, it is a reverse operation of multiplexer actually. Same combinational circuit, it performs the reverse operation of the multiplexer. So likewise in multiplexer we see many to one, here one to many. So it is a circuit with only one output and having many outputs. Okay, for example here 1 to 2 demux, 1 to 4 demux, 1 to 8 demux, 1 to 16 demultiplexers. So it is a process of taking information from one input and transmitting the same over to the several outputs. Yes, let me see how we can differ from the MUX. This is the block diagram. Only one input. For example, if you put as D, output segregated as is 4. 4, you can use 2, you can use 4, you can use 8 or 16, 32, likewise. Similarly, if it is 4 output, the selection line is 2. So if it is 8 outputs, it is 3 selection lines. Yes. The same thing, it is a logical symbol for demux, and this is the logical diagram for demultiplexer. So two selection line S1 and S2, and the data line same thing. Here I'm using the only the AND gate and NOT gate alone. There is no OR gate because I need a multiple output. Okay, single input, multiple outputs. So D is a single line, is connected to the all the AND gate. The remaining input line which will be from the selection lines. Here I'm using the two selection lines. So the two selection lines as an input, and one more data is given to the every AND gate. So the output Y0, Y1, Y2, and Y3. So this is the truth table for demultiplexer. So data input is the same single data. Selection line is 0001, 1011, 4 combinations. Here is for 1 is to 4. Output is 4 output, Y0, Y1, Y2, Y3. So for first selection line 00, the data input was going to the first output for Y0. For the selection line 01, the data input going to Y1. For the selection in 10, the data input going to other as an output for Y2. For selection in 11, the data input will be become as an output to Y3. So this is the overall operation of MUX and DEMUX. We can, I hope you understand well. So from that point, we can understand where we can use. This is mostly the application part of multiplex and demultiplexer will be in the communication channels. Let's see the overall structure, overall view. Application of MUX is a communication system. Communication system. It will be used as a MUX as in a transmitter side. So multiplexer allows the process of transmitting different type of data such as audio, video, whatever the data, different type of data will be accompanying at the same time in a single communication channel. Okay. So and also it helps to reduce the vast memory, reduce the copper lines, communication channels because I'm using this dedicated single line having more informations, and it helps to reduce the memory also. Okay. And in demultiplexer, the same communication system, but in the receiver side we are used. So the demultiplexer works at the receiver side. That meaning that the output signals of the multiplexer, yes, and converts them back to the original form to the data at the receiver. So this is the thing. So ultimately, the whole summation multiplexer will be at the transmitter, demultiplexer at the receiver. work together to carry out the process of the transmission and reception of the data in the communication system. So this is the whole summation application of MUX and DEMUX. I hope to understand very well of you students. If you have doubt, if you have any doubt, you can see the doubt clearing sessions. And thank you for attending these online lecture videos. Thank you guys.